Hello good people, I'm going to talk about molar calculations. In a departure from tradition, I'm going to give you the summary before I give you the content. These three triangles summarize quite a lot of mathematics that needs to be done in chemistry. Let me introduce the terms involved. Starting on the far left, we have capital N and an A in subscript. This stands for Avogadro's number. If we have only the capital N, this represents the number of particles. A lowercase n represents the number of moles, a lowercase m represents the mass in grams, a capital M with an R in subscript represents the molar mass that we get from the periodic table of elements, capital V represents volume, and a capital M that is also often italicized represents molarity. Molarity is the way we express concentration in chemistry. More on it later on. Suppose somebody is asking me to calculate the number of particles of a particular compound. So I'm after capital N. What does capital N equal to? To answer that, I look at the triangles. Number of particles are in the same triangle as Avogadro's number and number of moles. Because I am after the number of particles, I need to know what is the relationship between Avogadro's number and number of moles. According to this triangle, the Avogadro's number and the number of moles are in the same line, which means I should multiply them. And so my formula will be capital N equals Na multiplied by N. Now suppose that I have the number of particles and I want to calculate the number of moles. So this time I'm after number of moles. What is the relationship between number of particles and Avogadro's number? Number of particles is over Avogadro's number. And so I could say that N, number of moles, equals number of particles over Avogadro's number. And if I wanted to calculate the Avogadro's number, I could use the triangle yet again. According to the triangle, Avogadro's number is equal to number of particles over number of moles. So the formula would be Na equals capital N over lowercase n. The other two triangles are used in much the same way. Let's say that somebody is asking me for the mass of a particular compound. According to the triangle, mass equals number of moles multiplied by molar mass. So that is my formula. Lowercase m equals n multiplied by molar mass. On the other hand, if I was after the number of moles and I had the mass and the molar mass, based on this triangle, I could say that the number of moles equals to mass over molar mass. And so the formula would be lowercase n equals lowercase m for mass over the molar mass. And if I absolutely insisted in calculating the molar mass rather than looking it up from the periodic table, it would be mass over number of moles, which means mr equals lowercase m over lowercase n. We would do the same thing for the last triangle, the one that uses molarity and volume. Let me do that quickly. So based on the triangle, molarity equals number of moles over volume. On the other hand, number of moles equals molarity multiplied by volume. And if I wanted to calculate the volume, it would be number of moles over the molarity. There are two main reasons that I like this triangle. The first one is that the triangles allow me to quickly construct all of my formulas. And the second one is that these triangles show that the number of moles are central to most calculations. As I work through a number of examples in future videos, I will be referring to this tool, to these triangles. So let me put a miniature copy of it in the lower right. If you are struggling with mathematics and have trouble keeping track of all the formulas, I strongly suggest that you create this little tool somewhere for yourself as well. That is all for now, and I will see you on the flip side.